Hey guys, how's it going? Here's my best attempt to try to give you a little bit more guidance on some of the concave mirror problems. I have two fully worked out examples here along with the ray diagrams. Don't forget you also will have the answer keys posted shortly so you can check your answers as well as that simulation to help you with the ray diagrams. So don't forget about that. There'll be more help coming in Canvas, including a little bit of a help session so that you guys could ask some questions for me live. I'll get into that later. But first, let's go over number 2 on the concave mirror problems. Just taking a look here, one of the first things we need to do is obviously list the givens, but keep in mind that we have things given to us in micrometers and centimeters. I went ahead and just converted them all to meters. It doesn't matter what unit you choose as long as it's in the same unit. That's what's critical for these. You could have converted them all to centimeters if you would rather. That's fine. Taking a look at what we need to do here, we're trying to solve, as you can see, for P, that would be the object distance. How far away from the mirror, how far has this hair been placed from the mirror? So we want to know the object distance, P. Starting with this, we just need to do some algebra and use the mirror equation to solve for P. By plugging in the numbers here, you can see that because we have a virtual image right here, they did tell us that Q was negative in the problem. That means that it's virtual. That means that it's actually behind the mirror. We'll deal with that in a second. Plugging that in right here, we just have to be careful of our signs, and it results in the answer right there, as you can see, of 2.40 times 10 to the second meters. Also, then we're supposed to calculate the magnification. So over here, you can see the magnification equation resulting in a magnification of 24.6. And so there we have it. It gives us a positive number, which means it's upright, and it's a number greater than 1, so that means it's 24.6 times bigger than the actual object itself. Let's move on to the ray diagram for number 2. This one can be particularly confusing because it's a virtual image. Let's deal with that. I went ahead and copied over the givens here from the previous slide so you can see. We've went ahead and shown F and C. Remember, C has to be twice as far away as F. It also indicates that P, the object, is closer in than F, so we're going to draw it there. We follow our rules for drawing ray diagrams in our notes. We have parallel and through F. We have through F parallel, and then we also have through C, the ray that goes through C and bounces right back where it came from. How do we deal with this? Where is the object going to be? It's a virtual image, so it's going to be on this side of the mirror, but how do we figure out how to draw that? Well, here's how. What we need to do is trace back the rays that reflect off the mirror like this. This one reflects off the mirror. This one reflects off the mirror. And this one reflects off the mirror. Did you notice how I had to cheat a little bit? I had to bend the rays up a little bit so that they met at a point here. Otherwise, I would have went off the screen or off the page. That might happen to you too. Go ahead and tape a piece of paper to the edge of your paper if you need to. The whole point is that right over here is where the image should be showing up. This actually is Q. It looks much larger than the original object, and it's virtual. It shows up behind the mirror. It's also upright, so everything makes sense. And you can also verify this through the online simulator. This is the online simulation of problem 2 from the homework, and you can see that if we have an object closer in than the focal point, we do get a virtual image that's upright. It's also magnified. It's bigger than the original object. And because it's virtual, it's behind the mirror. Moving on to problem 3, we have a situation where we have a little complex algebra. I've listed the givens right up here for you. Hopefully you can see. They tell us that it's a real image. That means Q is positive, H is negative. We need to be sure to include that. Just a reminder to view that sign chart, that sign convention chart throughout this. You can see that we have 2 equations and 2 unknowns. And so I actually solved one of the equations, the magnification equation for Q, substituted that in to the other equation, and was able to get this equation. I was able to eliminate one of the unknowns, and if you follow the steps of the algebra, you can get P equals 37.5. Here's the ray diagram, laid out as specified according to the givens, parallel through F, parallel, and through C, generating an image that is real but inverted as you would expect. Hopefully this helped. There'll be a way to ask questions in just a little while. Hang in there and good luck.